Enline digital twin solution is unique in the market because it combines three main characteristics of the installation. First of all, an static parameterization of the electrical mechanical data. For example, type of towers, type of cables, electrical limits, electromagnetic limits. And then the second one is the weather situation. We have a very fine granularity about the weather condition relating very important variables like air temperature, wind speed, solar radiation, wind direction, angle of attack, weather limits, weather alarms, weather warning. And we also combine the electrical data requested at the connecting substations. Whenever we combine all of this, we have detailed information of the status of the line. And when we compare this to a common sensor installed in one span or in few spans, it doesn't consider, for example, a abrupt change on the wind direction, on how this will affect, on how the wind is hitting the cables, what is this angle, what is the effect regarding the convection. So all these considerations with a very fine granularity is what is going to give a detailed information about the installation. One of the biggest challenge to address the Enline technology is to compare it with physical information, even collected through sensors, weather stations, or any kind of field measurement. But this is common. We have faced this with many different customers where we could compare our results with results collected in the field, and we got pretty good outcomes. This means accuracy on the temperature estimation, accuracy on the weather situation, and even the maximum allowed load considering electromagnetic, electrical, and thermal limits of the installation. The concept of sustainability is applied throughout Enline's products. For the monitoring system and dynamic line rating, since we give to the customers the results of real-time and predictive dynamic line rating and maximum allowed load, the customers can use the existing installation up to its limits. And then we can even avoid the construction of new installations, new transmission lines. And this for sure will reduce the amount of CO2 and carbon footprint to the environment. For the power optimization, we also optimize the load flow and how we use our existing solar farms, hydropower plants, or wind farms up to this limit. So we avoid losses. We can optimize also the amount of injected active or reactive power to the grid. And with this, we can use better the renewables we have to feed the system. For the design optimization and also engineering, we could save up to 15% on mass of steel, aluminum, and also the insulators installed and requested to the design of new installations. This means that using intelligent algorithms to design this installation, we can save material and also avoid the carbon footprint. The recent partnership between Enline and Iberdrola was aiming to optimize the design of new transmission lines, so they could go to public tenders and be more cost effective. This means reducing CapEx and OpEx of these installations. To optimize these installations, we combine different alloys of aluminum, how we would prefillate, what would be the number of wires in the cables, how we would combine the distance between phases, and also complying with all the technical criteria like standards, in terms of technical specification and regulations. With this, we could save up to 5% on mass.